One of the hardest things in pre-press is how we deal with the color black. Here's our color wheel, and as you can see, black is supposedly the combination of magenta, yellow, and cyan, but it truly makes just a muddy brown. So they had to add black in as a fourth color. That complicates things. When you're talking about ink density or total ink that can be applied on the press and keep the right consistency on the paper so that the paper absorbs just the right amount and it dries in the right time and has the right color, there are limits to how much ink can actually be put on the paper. Each press has its own ink limit, and you can get that information from the printer, but we have to make sure that we don't exceed what the press is capable of printing. Now, in a happy world, we would put, if we wanted a really rich, dense black, we'd put 100% of all four colors. 400% ink is goo. It absolutely cannot be reproduced. Registration is set in as a default color in the Adobe apps because we need it for crop marks. No other reason. You don't ever select that for a black. It just cannot be handled. You can see what the density is in your info palette in Photoshop. You have the option when you go to your hamburger menu to pick two different sources that you want to find out what the values are, and one of them can be total ink, and it will tell you what the ink density is on a particular image. As I said, we don't technically need black, but we do. Over here on the left, we have a black made of RGB black, which is 0 red, 0 green, and 0 blue. Over here, we've got 100% cyan, 100% magenta, and 100% yellow without black. Look at the difference in the tone. This one looks reddish, brownish, muddy. Here we can see the right of this black circle is printed using 400% ink coverage. This one is using 300% ink coverage. You can really see the difference between the two colors. When you're defining what the specifications are for the total ink coverage, there are a number of things that you have to consider. One is the printing process, because every printing process is going to have its own set of requirements for the total amount. The paper that it's printing on is going to matter greatly. You're going to get a lot more ink density on a coated sheet than you are on an uncoated sheet. The speed at which the press runs, if it's really high speed and goes quickly versus slowly. And how many colors are printed simultaneously, since intermediate drying time is important. Now what that means is if you are running, let's say your press can only print maybe 2 colors at a time. So you put 2 colors down, you have to wait for it to dry, and you come back and you print 2 more colors, then you have a slightly greater ink density because you're not taxing the paper. For a standard ink density for traditional print jobs, it's going to be 320 to 340. Heat set web offset, which is the giant rolls of paper, is going to be 300 to 320. Standard swap is going to be right around 300. Newspapers are going to go down to 240 to 260, and most inkjet devices for digital is going to be 300 to 350. Now, one of the things that you can do is rely on your profile. Okay, the profile handles the ink densities. You can set that, or it will be set for a particular profile that you have, and Photoshop will make the adjustments for you. Now that's really awesome. That's one of the reasons profiles are so critical. Okay, here we can see an image just to show you what happens. The green in this screenshot is showing wherever the total area is beyond 280, and this is actually in InDesign that you can see this, and it shows you what's going to be problematic from an ink density standpoint. Right down here, total ink coverage, and it will show you if you have problems. Most printers, if you ask them, what kind of a rich black do you use? They will have a formula that they can rattle off the top of their head. This stems from the old days when you had to use physical screens in the camera to create a rich black color. You used solid screens and whole numbers to make it happen, and each printer had their own value that they used that worked well on their press. Because the printers are old dogs, don't like new tricks, they've stuck with that so that if you say, what rich black should I use, they're going to rattle off a formula. Okay? The bottom line is, if you're in RGB and you want a rich black, you use an RGB black, which is 000. And if you translate that into CMYK, it comes into some odd, uneven numbers, but it will give you a nice, rich black. If you are just making something black and the printer says, this is my black formula, go ahead and use it. They know it works, they can make it fly, and it will be fine. The important thing is to make sure that whatever black you're using matches the black that you need. You don't ever want to do text in black. Back to our bird picture. The background area in here of the bird picture was 000. So the border out here was 000. You can't see any kind of a definition between the frame and the image. Over here, this is the 000, but out here is the rich black formula that a lot of printers use. And you can see right here where the frame and this black don't match. That will jump off a page. Here, you can see the rich black in here, 000 RGB, and out here is just our plain old 100% black with the process color. It's really important that you make sure whatever black you're using matches what you need it to match. Oops, sorry. Okay, here is one of the biggest places to trip and fall flat on your face. In Illustrator and in InDesign, especially in InDesign, you want to go into your preferences and you go down to appearance of black. The default says display all blacks as rich black, output all blacks as rich black. That is absolutely the last thing you want to do. You want to make sure that you display the blacks accurately and you output them accurately. When you define a black, you want to use the one you've defined. You don't want to use some sort of an arbitrary rich black setting in InDesign or in Illustrator. This has caused so many problems for people over the years because when you look at your screen, if it's displaying as a rich black, you don't remember that you need to go back and make sure that your blacks are going to match. And when it's printed, it looks really, really bad. Now, I said that the profile takes care of ink densities for you, okay? And here's how it does it. You need to know what the process is. Again, what you're going to do is select the correct profile. And the profile is going to make some decisions based on the press that it's going to be printed on. The way that Photoshop and the profile is going to make adjustments for ink density is how it's going to handle the black, because black is our fourth color that gives us the most flexibility. One way is called GCR, and it stands for Gray Component Replacement. And what that does is it reduces the amount of processed colors and replaces with an equal amount of black. So if there's a color that's built of cyan, magenta, and yellow, and it has that particular value, that is a gray component, okay? Because a combination of cyan, magenta, and yellow is going to give you some form of grayish. So you can have a lot of cyan, magenta, and yellow ink and a little bit of black to create your grays. Or you can change that and have a little cyan, magenta, and yellow and switch out that gray component with black. What it does is it reduces the amount of ink you're using. Here's the thing to remember. GCR affects color. It goes into colors and it replaces different CMY values with black. And we'll look at some samples here in just a minute. The second way that it can do it is called UCR. And UCR stands for Undercolor Removal. And this is where black is used to replace cyan, magenta, and yellow in neutral areas. When there's an exact amount of cyan, magenta, and yellow, that gray component, okay, it replaces it with black. This does not affect color, it only affects the gray. Okay, only affects the gray. Now, let's look at an example. Here again, it shows GCR is used in dark saturated colors because it affects the color, and UCR affects the gray. You can maintain a better gray balance using UCR. Let's look at our giant gorilla here, okay? This image has maximum GCR, light GCR, and UCR, okay? This top image shows there are two different places, and it doesn't matter where they're clicked, but it's the same place on all of these images. That's what's important. Okay, on the pixels that are selected, you can see the total ink coverage is 100 in one place and 94 in another place. Using light GCR, it's 279 and 163. Using UCR, it's 307 and 155. This shows the image with the CMYK. And here's the breakdown on those very same points that are clicked, and it shows you using maximum GCR how much of the cyan, magenta, and yellow has been replaced with the black. Here you have much less being changed to the black. This is very similar to the light GCR. But if you look at this top image, they look the same. It's just a matter of how black is handled. Again, that's all done using your profile. Here's another example. This one shows heavy GCR, light GCR, and UCR. Okay, this is the CMY in all of these, and this is the black. Now, the color differences that you see here are my scanner. So they look pretty much the same on the printed sheet. these images all reproduce the same. So the thing I want you to look at is this black and how very different it is on all of these images. I said they were controlled by profiles. Okay, I'm going to show you where, knowing that you don't ever have to go in and do this. Okay, if you're going to create a custom profile, you go into the custom and you select this, and you get, here you can select GCR or UCR, you've got medium, maximum, and this is where it's actually done. I wanted you to see where it was done, even though you're not going to be the one doing it. Here's an example of the cyan, magenta, yellow, and black readings for a particular measurement for this color. This is a Pantone color being reproduced using CMYK. And these are all different profile settings to get this same color. Look at the difference in these charts and how it handles specifically the color black. Look at the difference between this one and this one. Okay, very, very unique percentages to each profile setting. Dot gain is another thing that we have to think about, and it's another thing that is controlled by the profile. Now, dot gain means when the ink hits the paper, it's going to spread. Think paper towel, water, paper towel. Now, it's not that bad unless, of course, you're printing on newsprint. But what happens when the ink hits the paper, it's going to spread some. Now, the basis of how much it spreads depends on how much surface area of the dot you have. Okay, and this illustration shows why most dot gain, the most dot gain that you are going to experience is going to happen in the 50% range. Okay, you can see here in a 20% dot, you don't have, it's a little bit of an area. Look how big this area is on a 50% dot. When you get bigger than a 50% dot, the dots start to overlap. And where they overlap, you don't have the outside area of the dot that's going to gain. So at an 80% dot, you actually have less dot gain than you do on a 50%. This is the largest area that you will have in dot gain. So the thing you want to look for, and you most especially want to make sure when you're checking out your final proof, is what do those midtones look like? Where I have 50% values of my color, does the color look correct? Now, the profile is set for dot gain. It will compensate for that, and that's the good news. But when you look at it and you want to see if something is changing because of dot gain, you don't look in the shadow areas. You look in those midtones because that's where you'll have the most dot gain.